All right. I do have a specific perspective on Angular development or web application development or software development, which is security. I'm the software security guy, and today I want to talk to you about security aspects that are specific to front-end development in general, and we're going to dive into some very Angular-specific things as well, right? Now, I don't know how about you guys, but when I went into the world of software security, I was overwhelmed by the amount of acronyms here. CORS and XSS and CSP and whatever, okay? I just want to shine a little bit of light on this world, and I want to explain the basics about these things because I think it is important for a software developer, for every software developer out there that does software for the browser to understand the basics of those things, right? So before we dive into those things, still I want to give a little bit of a high-level perspective on the topic of software security, like a 10,000 meters view on software security. So let's do that first. Now, a thing that I want to share with you, which corresponds to my experience, is there is no such thing as a software developer that does software development on the one side and then later on learns security as a second pillar of their skill set. In my experience, people that are good in software security are just good developers. It's just the people that have a very deep understanding of everything that is involved in their development environment, right? So in order to be good at security or software security, you need to be a good developer. Just continue learning. So if you start as a software developer, like I did as well, write messy, insecure code that's not testable, that's not where functionality is not encapsulated right, it's not testable code, there are no unit tests at all. It just works kind of, but it's not sustainable or maintainable software. Now the next step would be write clean code, then maybe write testable code, write the actual unit tests. That started somewhat late in my personal career. Then start hacking your own code, start getting an interest in how things work and how to circumvent security controls maybe. And then like the last skill level or what very high skill would be write secure code. And that only starts once you start understanding very well what's going on in your development environment. And development environment includes everything: the programming language, the framework, the container, the operating system, the protocols that are used to interact between the parts of your software, right? So in my personal experience, an in-depth understanding of your dev environment will almost automatically make you a better security engineer, right? It's not the thing, software development and then security as a side note. No, it's supposed to be one thing, right? Now, security has two very common problems, and I want to share a tweet of Christopher Himes that I saw recently. He said, the number one problem with the community is ego. And by ego, he means something like, you know, I'm the cool hacker, I hacked the application, you're doing shit. That's not how it works. Security guys need to be part of the development team and the development spirit in order for this to work, right? Security people must not be the people that come from the outside and say, this is shit and that is shit, right? The second thing is the fixation on niche risk. Now, if people go on security conferences where the latest and greatest hacks are presented, that's basically a good thing for people that are in security. But at the same time, most software developers, I think, have a hard time getting the basics really done and really down. And this is where we need to focus on. Security conferences are something for security guys to get the latest hacks. It's a good thing. But still, we need to focus on the basics. And he says, my hero team is the one who gets the basics right and shares how, right? This is what I want to do today, how to get the basics in security down, and I want to share with you how some of those things are done. So let's get the basics right and share between each other how we did this. The third thing, and then I'm going to stop this, you know, old man's wisdom shit. When you find security problems late in development lifecycle, like when everything is deployed, it's in production, and then somebody finds a security issue, it starts to get very expensive when you want to try to fix that problem. If it's something in the architecture that haven't considered from the start, things start to get very expensive. So I don't know if you heard shifting left in software security means just starting to think earlier in the software development lifecycle. For example, writing a requirements document that does not only contain functional requirements, but maybe also security requirements to get you an idea how sensitive the data is that we are processing or storing or persisting in our application, right? Or for example, in the architecture and design phase, think about the security architecture, security design, what implications our design decisions have in the software development. So that's meant by shifting left. We want to start earlier. So we need to shift left in the software development lifecycle in terms of security. Start thinking earlier, right? But enough of that old man's wisdom shit. We're going to go into technical details right now. I want to start with a certain vulnerability that's called cross-site request forgery. I start with this one because in order to understand what's going on in this attack, we need to understand two things. The first thing is the same origin policy in web browsers, how it exactly works. It's not too easy to understand, I have to admit. And the second one is authentication in web browsers, implicit, explicit authentication. So what is cross-site request forgery? Before we dive in, we want to clarify those two things. The same origin policy in a browser limits the way two different origins can interact with each other. So imagine you have one website open in one tab, you're logged into the website, you have another website open in another tab. You cannot just arbitrarily send requests from one to the other and get and post stuff. You can with some exceptions, but it's not arbitrarily open, right? You cannot read the cookies or the local storage of the other site. That's not possible. The same origin policy is going to limit that. I said origin. What exactly is the origin in a web browser security context? I wanted to award you guys with some pets. Are you going to find some? No? Okay. All are gone. There wasn't pets. I wanted to award the guys with the right answers. But anyway, you're awarded with fame. What's the origin? What does the origin contain in a web browser? Oh, there you go. Thank you. Domain is one very important, probably the most important part, but there are two other things that are part of the origin. The protocol or scheme. There's one more. Who said port? Huh. Very good. It's three things. It's the scheme, it's the domain, it's the port. If one of those three things is different, only one is different, means it's a different origin. Although you're maybe on example.com, HTTPS, port 443, if there's another site, HTTPS example.com, port 8443, that's a different origin. So here are some examples of, if this is the original origin, store company com, then HTTP, which is not recommended, by the way, then this is the same origin because it's the same scheme, domain, and implicitly the same port, 80, which is the default port for HTTP. If you go, for example, for a subdomain, it's not the same origin anymore. Subdomains are different origin. So api.example.com is a different origin than example.com. Keep that in mind if you do your API on a different domain, right? Your REST API, for example. So these three things must be equal. Now, what is allowed generally in the same origin policy and what is not allowed? And this is very counterintuitive because cross-origin writes are typically allowed, whereas cross-origin reads are typically prohibited. For security guys, this is very counterintuitive because you would think reads are permitted first and then we can write. That's not the case. Now, why is that? Why are cross-origin writes allowed in some cases? Any idea? What is the thing that we want to support?
Because sometimes you can read something which might be a harmful script in the end, right?
Well, the exception, not really. The exception that cross-origin writes are allowed is cross-origin form submissions, right? We have a classic server-side rendered, not Angular, old world. Think of the old world. HTML form with a form action that goes to a different origin. And you issue a post request over to a different origin. That is still allowed even in 2019. So the browsers do not forbid that. That's a legacy that we're still carrying with us in browsers. I have a login form that points to a different origin. You can post there, it's allowed. But that's one specific exception to that cross-origin write. Now, cross-origin embedding is a totally different story. Who of you has ever imported, say, the AngularJS library from a CDN, a content delivery network? I have. Many of you have. And it worked, right? It was a different origin. It was CDN, I don't know, Google, anything. you could include that script, it would work. The only exception is that you cannot literally read the contents of the script byte by byte. That's not possible. But you can run it in the context of your site. So cross-origin embedding is typically allowed as well. Think of this just as a little bit a counterintuitive thing. Cross-origin writes, cross-origin form posts, the legacy thing, is allowed. Cross-origin reads are not possible. Now let me ask you one thing. If you have your site and you do an AJAX call to a different origin, get request, okay? You want to get information. Is the request going to go through? Is it going to go over the wire? Yes, it is. Is it going to be an authenticated request? So are, for example, implicit authentication like cookies going to be included in that request? It's an authenticated request. It's going to be with cookies. Now, what's the limit? It says here cross-origin reads are typically prohibited. Now, what's the deal? You're going to be awarded with this awesome pets. That's kind of a contradiction, right? There's a request going to go through. It's going to be authenticated. Everything's going to be all right. But why does it say here cross-origin reads are prohibited?
The response will be blocked.
The response will be blocked. Gotcha. So you're not allowed to read the response in JavaScript. It's going to appear empty. You can issue the request. It's going to go through. It's going to go over the wire. The browser's going to receive it. There's going to be TCP communication to that other host. But in your originating in JavaScript, you cannot read the response, and that's why reads are prohibited, right? So that's the deal. That's kind of hard to understand. It took me years to understand this, right? Now, one more thing, implicit versus explicit authentication. Implicit authentication is everything that your browser does automatically when you issue a request somewhere. Say, for example, you're on example.com, you're going to issue a request with AJAX to say api.example.com, different origin, as we said, the domain is different. Now, if you have a cookie set for that target origin, the cookie is going to be attached to that request automatically. You don't have to care about this yourself in JavaScript or anything. You have to set the with credentials to true to be very precise, but your browser is going to handle the rest, okay? This is implicit authentication. It's going to happen implicitly, automatically. Now, we also have explicit authentication. That could be, for example, an authentication header or any custom header that you set, for example, with an HTTP interceptor in your Angular application, where you take the local storage session token and you put it into a request as a header. That's explicit authentication. You have to do that explicitly in your code. It's not going to happen automatically. Your browser is not going to take care about this for you. Who of you uses explicit authentication, something like a custom header, authentication header in your application? You guys don't have cross-site request forgery. Yes. The other guys do. So we have to, the explicit authentication guys, you can have a beer. It's going to take 5 minutes for the rest to explain. He's doing it. Now, this is the course of action for this cross-site request forgery attack. Say this is the browser of the victim. This is the banking application, right, where we are logged in. So we do a post login request and we get back a session ID. So in the browser, we have an implicit authentication, a cookie with a session ID inside. Now the attacker lures me on their site. They send me an email and I click on the link and the site opens on my browser on a new tab. Now they can embed a form element into their site, right? It's in their origin, under their control. And they have a little script in here that automatically submits that form to the bank site. So it's going to issue a post request with, I want to create a transfer to myself with 1 million euros, right? That wouldn't work for my account, unfortunately, but you get the point. And it's going to issue back a 200 OK, right? The only thing that happens in the browser is that the web page is going to be changed to bank.com. So where attackable .com was, there's going to be bank.com. I'm going to be redirected there, right? But if that site over there does not have any countermeasures against this, it's going to work. That's cross-site request forgery, okay? So let me summarize. When does this attack work? A little bit of a server-side thing, but also concerning the browser side of it. So a CSRF attack works if the server accepts write operations via get, post, or head, not usually done for write operations, but that's important. It needs to be get or post. Patch, put, delete is not going to work. With standard HTML form content types, an HTML form, a classic form, can only have 3 different content types. It's XWWW form URL encoded, that's the default. It can be multi-part form data, is used for what? Who said uploads? There you go. I'm sorry. Multi-part form data is used for file uploads, right? It's that you see that boundary thing in the HTTP body. Or it can be text plain, which is also a possibility for forms. It needs to be one of those 3 things that are accepted by your server, right? And there needs to be implicit authentication. So if that cross-origin request happens here with this form, the cookie needs to be attached automatically because the attacker has no means to grab the cookie of the target site. Same origin policy does not allow that, right? So implicit authentication. And there's one more thing that's important. And no non-standard header is required. So if the server says there is any non-standard header, such as x-angular-meetup::true, right? Something, can be anything. If your server requires that to be part of the request, that attack is not going to work anymore, right? Because that's going to issue, that's going to, what is going to happen if you attach a custom header? A course pre-flight request. We're going to talk about that. So these are the things. Your server side needs to accept those things, then this attack is going to work. So let's turn this around and think about how we can, what we can do about this attack. So the first thing, you have to strictly distinguish get from non-get on the server side. So tell your server side guys to be strict about not get and non-get, right? Don't accept a post request with get, but that's not your business, really. And then either use explicit authentication, right? Explicit authentication is a non-standard header, is going to cause a pre-flight request. It's not going to, the post request that goes to the bank that says 1 million euros to Thomas is not going to go through because the server is going to issue an options response, options request and a response to it. Or what you could do as well is only accept a non-standard format. So if you only accept JSON on the server side, attack is also not going to work. Why? Because with a standard HTML form, a classic one, JSON is not possible. It's only that classic x-www form URL encoded or multi-part form data, no JSON. Or you could just use a non-standard header, for example, x CSRF protection true, and enforce this header on the server side. Now this is a very cool solution for you Angular guys, because it's very easy to set a header upon every request with an interceptor. You can just set that header, make sure on the server side it's there. There we go. CSRF is solved, right? That's why I tell you guys, there are very easy solutions for single-page applications. Just set a non-standard header, just check it that it's there on the server side, you're done. No, you probably heard about CSRF tokens and stuff like this. Forget about all that. If you have Ajax only and a single-page application, no need for this, okay? Complicated, blows up the design of the application, forget it. Single-page applications, custom header. As a defense in depth, if you use cookies for authentication, you could use the same site cookie attribute, which makes sure that the browser does not automatically attach the cookie when there is a cross-origin request. That's even supported in Internet Explorer. It was backported into Internet Explorer. Really, no joke. Go to caniuse.com, same site, it was backported to Internet Explorer. First time in history. Something, security feature backported to IE. So proud of Microsoft. Good, so that's CSRF. I wanted to place this first because same origin policy, important to understand for other stuff, like for example, this cross-origin resource sharing. Who of you has fought with this, had a fight with access control headers? Everybody is fighting with this because it's hard to understand. We want to dive into it and talk a little about how it relates to the same origin policy. Now, question to you guys. Just saying, you've been going to be awarded with this. Is cross-origin resource sharing, can it be used to strengthen or to weaken the same origin policy?
Both. Weaken.
That was a really... it is weakening the same origin policy because with this, if you have cross-origin requests, for example, you have your single-page Angular application at example.com, and you want to issue requests with ajax to api.example.com, and you want to actually read the response, which is kind of important, you have to add a course header to the response on the server side, right? So let's have a little look at this. So cross-origin requests can be done with this. Same origin policy can be weakened in a controlled way. So before it was forbidden by the same origin policy, some of you have done something like JSONP, really old school, equivalent to course. So we have example.com. We want to talk to a REST API on api.example.com. So on this API, we could, for example, respond with an access control allow origin and then example.com. That would open up API requests from example.com to api.example.com. Sorry? Okay. So there are two things, simple requests and pre-flighted requests. A simple request would be something like a GET request that goes to the other domain and just tries to get some public data. You send it via JavaScript, and then the server is going to respond with, okay, first the request, sorry. The request is going to include an origin header. The origin header is going to tell the server this request originates from there. Cannot be manipulated by JavaScript. That's the whole point of it, right? So a browser that supports cross-origin resource sharing is always going to set this header, and you cannot manipulate it with JavaScript, right? It's there, and it's always going to be there. You cannot control it. And then the response could be something like access control allow origin asterisk. This is not a recommendation, just to make that clear. Don't do this unless you're a public API with public data, right? The Wikipedia API does this, but it's public data. It's not something that's private to some people. So that's just an example. Now there are pre-flighted requests, and pre-flighted requests are such requests that, for example, are a method that's other than get and post, or a custom header is set, or a content type that's not standard for HTML forms. Remember, same origin policy. So it could be something like you set a content type that's not standard. Application XML is not standard for HTML forms. And you set a custom header as well. So why does this JavaScript code trigger a pre-flight request? First, because it contains a custom header, and it has a content type that's not standard. Then what's going to happen in the browser, you might have seen this in the network tab of your DevTools sometime. There's going to be an options request, and that options request is basically there to go ask the server, look server, is it okay to send a post request with a custom header and a non-standard content type? It's going to ask the server. So you have it, the server side, the backend guys have it under their control whether or not to allow this. So the server could, if it is allowed, send back access control allow origin, that origin that was sent by with the request. And they could say post, get, and options requests are okay. And it could say allowed headers are these two because these two are non-standard, right? Access control max age, what's that going to do? Who's that caching? There you go. So this tells the browser to remember that information here, that it is okay to send to this URL a request with those options and not issue options request every time. It's going to be a performance issue if you have a high volume site, right? Remember that information. And the server could answer, then it only sends the post request. So the next step is options request back, post request to the server, as soon as the browser sees that it is okay to send a request like this. Right. So a little developer's checklist. Do not set access control allow origin asterisk. That can only be set for GET requests, by the way. Post requests do not allow this by the standard. Do not set this unless you're a public API. And what I frequently see, I'm a penetration tester, by the way, and I see these things all the day, every day. Access control allow origin and then reflecting the value that came with the origin header with the request. Don't do this, please. Okay? Use a whitelist. Have a configuration set version with an environment variable, for example, at their server side. And if the origin is within those origins that are allowed, then send back this specific origin. Use a whitelist, please. I've seen this so many times. This is like cross-site request forgery, but better for the attacker, right? They can read and write everything. They can do anything, right? Don't do this. And only whitelist the allowed headers and stuff that's actually allowed, right? Don't do whitelist everything. That's bad for your security. Right, now we're going to get into the next topic, cross-site scripting. Cross-site scripting is an attack that is very relevant for single-page applications. And Angular has some pretty cool countermeasures against that, and we're going to dive into those and have a look at those countermeasures, which are, I would say, better than in every other popular SPA framework out there, in my personal opinion. Cross-site scripting is about executing script code in other people's contexts. Imagine, for example, you have a web page where you have a comments section, and in these comments you can, I don't know, format your comment. Use bulleted lists or tables or bold or italic text and stuff like this. Now, this is usually converted to HTML text. You push it back to the server, and you do not do any escaping or anything on the client side. So you could potentially execute script code. You could embed a script tag. And then if any other person over there reads that comment or opens the comment page, the script code is going to be executed in their context. And you can do anything with their user session. You could try to steal their session token if it's stored in local storage. You have access to it via JavaScript. You could possibly use read the cookie if the session is stored in a cookie, unless which flag is set? HTTP only. Who said HTTP only flag? Who said it? You said it. Very good. HTTP only flag with cookies prohibits JavaScript from reading the value. So that's the thing. Now let's have a closer look. So hopefully the development environment here works. Oh, there it is. Great. So it's a little bit hard to see. I'm just going to continue anyway, right? I hope you can. I will try to explain my points. Now, there are a couple of dangerous or potentially dangerous things that you could do with Angular, and I want to show them to you. But it's a blacklist. Don't do this, right? Where could you potentially insert script code? Think of an Angular template. Where could maybe image source attribute could be a place for inner HTML is exactly the thing I wanted to say. So, for example, you have this comment. Think about that comment section, and you have HTML code in there because you want people to have options for formatting their text. Now, if you want to output that HTML code and it's actually HTML, you need inner HTML so that the browser renders that as HTML and does not show you, the brackets and anything in the HTML code. You want it to be rendered. So inner HTML is an option they could use for this. So I have this code here. There is an inner HTML. This is a products page. And that products page has some information about, a list of products. It looks like this, right? And let's just think that somebody can change the description of that product, and I have used inner HTML here. So maybe you can see it here, it says inner HTML. So the product description is going to go into that span element as inner HTML. Now let's suppose that somebody can manipulate that and put some script code in there. I'm just simulating this by changing the product description here. I'm going to put some script code in here. So for example, script, let's say alert, the classic, close the script tag. I'm going to save it. What do you think is going to happen if I save this? Is there going to be an alert box? Yes or no?
No.
Who said no? Oh, that was better. There's no alert box here. But if I have a look at the console, come on. It says here, sanitizing HTML, stripped some content, see some link with access as contained. So AngularJS has a sanitization method built in. It's going to sanitize this code, so there's no script code possible. So if I put a script tag in there, it's not going to work. There are other places where I can place script code potentially. Name some. In an HTML, I can put a script code, okay, but which HTML tags or attributes can also contain script code?
Link.
A link can contain JavaScript colon, for example. What else? JavaScript event handler. So every event handler can contain script code. If you write, for example, a div and on mouse over equals, there you can put script code. All these things are going to be stripped out by Angular because it carries a built-in sanitization method. Now, it is the only one of the popular frameworks, Vue.js, React, and Angular. I would name those three as the most popular ones. That carries a built-in sanitization method, which is very cool. Do you know inner HTML how React calls that function? Dangerously set inner HTML. So they are warning you as a developer that you should not use this function. So they just call it, Angular just calls it inner HTML, and it's safe to use. So this is pretty cool. Right, so, but it also could go into a link. Let's try that out as well. I have an A tag here, an anchor tag, which has the product link inside. And the product link, let's suppose, can also be manipulated by an attacker. I just scroll down to the products.ts, gonna open the file, gonna go over here to that's a link. And I'm gonna put in here JavaScript colon alert, and the old classic alert 1. Just let's see if a pop-up happens. Let's go back here to the console. I'll take some time. Same thing, it has a sanitization method. So everything that could potentially contain JavaScript code, like links, like event handlers, everything is going to be sanitized. So that's pretty cool. Now, developers don't always go that straight path. And there are going to be situations where you might want the script code to be executed, There are ways around this, and I'm just showing this to you in order so that you do not use it. Let's have a look at, where is it? It's here in the module. I created a pipe right here. So I have an unsafe HTML pipe. So I can output something and type pipe and then something, and it's gonna be filtered. In this case, not gonna be filtered because I say here bypass security trust HTML, which is gonna turn off the whole protection. So I can actually insert script code. Right. So if you go back to say, for example, my products page, it's all a little slow here. Oh. Yeah, thanks. The display is lighter now. Very cool. I go back to this products page, and instead of just having this description span right here, I say product description pipe unsafe HTML. Okay. Failed to download the font, okay. Head back to the product section, see. It just doesn't reload for a reason. Port closed. That whole thing is a little unstable. Just imagine there's a pop-up box coming. So if there was an internet connection, there would be a pop-up box, and I'm afraid internet connection is just down. It's okay. We'll just leave it with this, and I'll tell you it's not recommended to do this bypass. So there are ways in Angular to bypass that security function, and that you should not use this. So a little checklist for Angular developers, cross-site scripting. What I wanted to show you is stuff like, for example, document.write is also a function that can contain HTML code. If there's a script tag in there, you can actually put script tags in there and they're going to be executed. That's what I call DOM Kung Fu, right? There are good ways in Angular templates that you can use to output your stuff. Don't do DOM Kung Fu. Don't manipulate the DOM directly, but use the ways that Angular gives you, right? And you're going to be on the safe side. Don't disable those security functions. So be very careful if you do that. Bypass security trust something. There are functions for HTML, for links, and for everything. Don't do that unless you're very, 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 very sure that the data you're inserting there is coming from a trusted source, right? Not input by any user or anything in your application. Also be careful with external libraries because they could do DOM Kung Fu as well. Check them for known vulnerabilities with npm audit, for example, to check whether they have some known cross-site scripting vulnerabilities in there. Good, so cross-site scripting, if in Angular, in short, if you go the easy path and use the functionality that Angular gives you, you're pretty much on the safe side. But you can never be very sure if there are many developers involved in a project. Some of them are not so aware of security. There could be something happening, right? And there's a very good defense-in-depth mechanism against cross-site scripting, which is called defense-in-depth against cross-site scripting, second line of defense. What's the name of it? Anyone? Anybody heard of the content security policy? Yeah? Never? Some of you did. Content security policy was made as a defense in depth against cross-site scripting. So if we have a huge application landscape and we're not very sure whether there might be cross-site scripting or not, this can be a very good second line of defense. So the thing is, it's not a matter if you will introduce cross-site scripting vulnerabilities in your application, but when, right? I know this is true. I see this every day. Even yesterday, I tested a React application that used that dangerously thing, right? Cross-site scripting. So there you go, although they used a very modern framework. So a word of warning, content security policy is not the solution against cross-site scripting. You should still take care about it in your application. It's only defense in depth, so second line of defense. Correct output encoding, and Angular does that for you, is the only real solution against the problem. But what is the content security policy all about? It is an HTTP response header, so your server answers with that header when it serves the index or any HTML page. It's not relevant for APIs. People set this on APIs, not relevant. Only for when you give back an HTML resource. So it looks like this, content security policy, and you can specify directives, for example, script source, self, or cdmexample.com, which means browser, the HTML page I'm giving you, it only might load dynamic stuff like scripts from those two origins. It can be that CDN that I host or somebody else hosts, or my own origin, that's the self thing, right? If I do I embed a script that has an external source or interacts with anything external, it's not going to work, right? I tell the browser, don't accept any script imports from anything else. So I have 3 examples here. I have an import from cdmexample.com, jQuery, whatever, whoever uses this nowadays, is going to work. The script source /js app.js is from the same source itself. It's going to work as well. But as soon as an attacker mounts a JavaScript attack and says, I want to import a script that comes from evil.com punage.js, it's not going to work because it's going to say, refuse to load the script because it comes from something that is not whitelisted in your content security policy. That's what it's basically all about. Now, there are a few implicit things that come with a content security policy. And that's the most important thing, actually, is inline scripts are disabled, are not allowed, right? There must not be any script tag that contains JavaScript within your HTML. There can be scripts that are loaded with an src attribute from your own site, but not inline, is completely forbidden. An empty content security policy is going to forbid inline scripts as well. That's default. Now, what also comes with it, event handlers and attributes are also disallowed. So no JavaScript event handlers are possible within the HTML. That's important. Angular is still going to work because everything is inside external .js files that are going to be bundled with your Webpack or whatever you use, right? So that's okay. Also functions like setTimeout, setInterval, they have an option to, you can pass JavaScript code directly with a string to those functions. That's not going to be allowed neither, right? So everything that's JavaScript code that's directly visible in your HTML is going to be disabled, not allowed. There's one very cool feature of the content security policy, which is called the Report Uri. So if there is any violation in your application, so somebody attacks it or a developer has forgotten to remove that one inline script or something like that, you can specify where a report is going to be sent. It looks like this. It's just a JSON that contains which page it was, which policy was violated, and stuff like this. So that's also a good way to get started with a content security policy because there is a report-only mode. So if you set the header as content security policy report only, it's going to mean it's not going to be actively blocking things. It's only going to be reporting if there's a violation. So you can install a content security policy and see if it works in production. You can set this in production. It's not going to break your application should you forget to remove an inline script or something like that, or an event handler that's directly in your HTML, right? Now, if you have scripts that load other scripts, think of Angular, I don't know, dynamic modules that are loaded on demand. So there could be scripts that load other scripts. With Content Security Policy version 3, a new feature came into this, which is called strict dynamic. If you specify strict dynamic, it's going to allow your scripts that are already whitelisted to load other scripts. That makes it easier to deploy in more specific situations. So, checklist. If you want to deploy a content security policy for your site, what's that going to mean? It's going to mean extract all your inline scripts and JavaScript event handlers. That's easy with Angular. If you have a Webpack and you have your app and your vendor.js and your styles, it's all external anyway. There's not going to be likely any inline script. And if you have an inline script, just put it in an external .js file and include it with src equals, right? No inline scripts because they are disabled. They are not allowed by default with the content security. That's what content security policy is all about, not having inline scripts because cross-scripting works that way. Define your directives, where your scripts are coming from, whitelist them. Start with report only, because then you're not going to break your application. If you get reports in your production environment, it's going to mean that there's something wrong or there might be some mistake somewhere. You can go and fix it. As soon as you don't get any reports for a longer period of time and you start gaining confidence in what you did, you can just remove the report only. But I would keep the report URI because if somebody mounts a cross-scripting attack on your application, you're going to notice it. And that's pretty cool. Good. So that's content security policy. There's more to it. There's nonces and hashes and stuff like this. Not going to cover this today, but to give you a general idea of what content security policy is all about. It's a defense in depth against cross-scripting, and it's pretty awesome. Google has deployed it on 99% of their services. So it's something that can be done in production on a wide range of applications. Totally possible. Now, one last thing, acronym sub-resource integrity. Who has heard about sub-resource integrity? Wah, wah, wah. What is this all about? SRI, the acronym for it. Now, the problem that we have is, for example, you have an application and you want to ensure that there's high throughput possible in your application, and you have your .js files and you put them on an external CDN somewhere. Or you just take standard JavaScript files from your external CDN to reduce loading times, to reduce the server bandwidth and stuff like this. Now, the risk here is that if that CDN is compromised, your site is going to be compromised as well, because that attacker can just change the JavaScript and execute arbitrary JavaScript in the name of the users of your site, which could be a problem. If you have, 20 different CDNs included in your site, that could be a security problem. It's a risk. So what could we do about this? Sub-resource integrity is a way to check the integrity of the JavaScript file. So what it does is you have a script tag with an external script source, and then you have this integrity attribute that says, here's the hash of the contents of those files, of this file. The browser is going to download it, it's going to check whether the hash equals that file, and is only going to execute if the integrity is okay, right? So the browser is going to check if something was changed. So if somebody changes something on that server, on that CDN, because it was attacked or something, your browser is not going to execute it. It's going to break the site, but at least the attacker does not manage to execute code in the browsers of your users, right? How can you recreate hashes of existing URLs? There's srihash.org, for example, where you can just put in the URL to the JavaScript file. It's going to create the whole script tag, including the integrity attribute. Developers checklist for you guys. If you want to use SRI, please check whether your CDN actually supports this. So if you go to the CDN's webpage and the script tag includes the integrity stuff already, it's going to mean that they're supporting it. Why do I say this? Because if they, in retrospective, change, for example, the minifying algorithm of that JavaScript file to make it a little bit smaller, although if in terms of functionality nothing has changed, the hash is also going to change, and that would break your site. So only do this if the CDN or provider promises not to change old versions of the libraries, because otherwise it could break the site. Many CDNs that have JavaScript files support this and have the link including that integrity hash already in the website, and this is kind of an implicit promise not to change old versions of it. One very fast thing, last part, WebSocket Security essentials. This is nothing that is really important for you front-end guys, but tell your back-end guys when you get home or into the office that they should check the origin header on the server side, because if they don't, you know, 2 tabs open, attacker.com on the one side, they could issue a WebSocket connection request cross-origin, and if that origin header is not checked, they can read and put data or use the WebSocket in the name of the user that's logged in. So tell your backend guys, check the origin header, very important. Right, so let's wrap up the whole thing. First, we did a 10,000 meters view on software security, and I said, according to my experience, somebody who's good at security engineering is basically nothing but a very good software developer. So make sure to sharpen your skills and make sure to have an in-depth understanding of everything that's going around in your development environment, including all the bits and pieces. That's going to make you a good security engineer almost automatically. Now, let's get the basics right. Don't think about niche risk and the latest and greatest hacks. They are most probably not important for you guys when you do software development in your everyday business. Focus on the basics and get those right. Share how you did this. And we need to start thinking about software security a little bit earlier than that. Now, a very fast wrap-up of the web security for front-end devs acronym thing. I hope you have a little bit of a more deep understanding of those things. Cross-site request forgery. Setting a custom header is the easiest countermeasure against this attack for you Angular developers. For cross-origin resource sharing, just don't whitelist everything or reflect the origin. That's going to be bad for the security of application. Cross-site scripting, don't do DOM Kung Fu. When you do Angular and you stay on that default path and do what's in the documentation, you're going to be fine. 99.99%. Content security policy is a good defense in depth against that. It's a server header that's set in the response. You can use it and start with report only to make sure you don't break anything in production. Sub-resource integrity, if your CDN gets hacked, you can make sure that at least the changed script is not going to be executed in your context. For WebSocket security, not really important for you guys, but for your backend guys, check the origin header and make sure it's coming from the own origin. I didn't even present myself. I'm going to do that now. I'm Thomas Konrad. I work as a penetration tester and software security guy at a research center for information security that's called SBA Research. It's here in Vienna in the 4th district. Still took us almost an hour to get here because we just missed that U4 thing and went around I don't know where. So we fucked that up a little bit, but we were on time anyway. So what I do is penetration testing, secure software lifecycle things, security automation for development. I'm a little bit of a software developer as well, right? So I do software development as well in my company. And we also have a meetup, it's called Security Meetup, where we talk about things like these, but on a broader perspective. I'm also the founder of the Sec4Dev conference, so another conference I'm shortly presenting. It's called Sec4Dev. It's a conference and bootcamp that's about security, but specifically for software developers. It's not latest and greatest hacks, it's getting the basics down for software development, right? So make sure to follow @sec4dev if you're interested. It's going to take place in February 24th to 27th, 2020, next year. Very close to here, so at TU Vienna. And yeah. Cool. That's it. Thank you very much.